Welcome to this class, SS2 class, SS2 maths class. We are still on cycle geometry. This lesson is lesson 11. This is lesson 11. In our last class, I remember that we started cyclic quadrilaterals. We solved questions on cyclic quadrilaterals, and that's what we will still do now. Cyclic quadrilateral. What I want to do right now is to solve the question I gave you as assignments. I want to solve that question. After that, if we have time, we'll solve another one. Okay, we have a cycle. Here's the cycle. We're going to draw the shapes inside. We have a cycle. This is center O. This angle is 116 degrees. And this is the angle we are asked to find. This angle is 25 degrees. Yes, this is the question given to us. Let me give it names. A, B, C. Now let's face the solving of this question. If I want to find this angle, looking at all the theorems, I may not see the one that is much suitable to get this very angle here. And that's the angle I'm to look for. So on my own, I can decide to do some things. Despite this is the angle I am asked to find, looking at this shape, I can conveniently get this angle. Any angle you can conveniently get, just get it and keep it. It could be useful later on. How will I get this angle? This angle is related with this very angle here. This 116. They are related. What's the relationship? Angle at center is twice angle at circumference. If you can remember one of the theorems. Because this very angle 116, it has the same takeoff point and landing point. The angle started from here, it moves here and landed here. It took off from A and it landed at C. This angle too took off from A, touched the circumference and landed at C too. So this angle and this angle, they have the same takeoff and landing point. And what's the second thing? They are facing the same direction. This one is facing down, this angle is also facing down. So they have the same takeoff and landing point, and they are facing the same direction. They are both facing down. Those are the main properties. So angle at center is twice angle at circle. So if angle at center is 116, which is twice this very angle, it means this angle will be half of this one. If you want to get half of this, you simply divide it by 2. Divide it by 2. That will be angle ABC. Angle ABC is equal to ABC is equal to 116 divided by 2. If you do this division, you will get 58. You will get 58 degrees. So I've gotten this angle 58 degrees. This is the angle I'm looking for. But any angle that can serve, any angle that match with any of the theorem, please go ahead and find it. So at this point, there is no any other relationship. But if you think very well, you will find a way. Looking at this, I may decide to produce this line. I may decide to produce it continuously like this to this very point. Yes. So that it will become a straight line. I can make this line a straight line. That will help me to get this angle. I can get this angle. And if I get this angle, with this angle, I can find this angle because I have a triangle here. That's the reason why I decided to produce this line to get this angle. And once I get this angle, I can also get this angle. And that will be nice. Then I'm going to be having a triangle here. I'll be having a triangle here. Knowing this angle and this very angle, I can find this very one. So that's the tactics. So if I want to get this angle, I'll use sum of angles on a straight line because this angle 116 and this very angle here, they are all on this straight line. Sum of angle on a straight line is 180 degrees. So that is angle 116 plus, let me call it angle y. Let me just call this angle y plus angle y is equal to 180 degrees because sum of angles on a straight line is 180 degrees. I will collect like term, that is to say I'm going to take this 116 to the other side, and as it crosses the sign of equality it will go and become negative. So this y is equal to 180 minus 116. 180 minus 116. That will give me 64 degrees. That will give me 64 degrees. I found this angle at 64. So at this point I can find this angle also. Using sum of angles in a triangle is 180 degrees. That is 25 plus 64 plus, let me call this angle P. Let me just give it a name, P. Plus P equals to 180. Sum of angles in a triangle is 180 degrees. If I add up 25 plus 64, that will give me 89. That is 89 plus P equals to 180. At this point, I will collect like term. This 89 will cross to the other side and to go and become negative. So my P equals to 180 minus 89. My P is equal to 91 degrees. My P is equal to 91 degrees. Now that I've gotten this P to be 91 degrees, I can conveniently get this one using sum of angles on a straight line is 180. Sum of angle on a straight line is 180. So I can call this angle angle Z. That is angle Z plus angle P equals to 180, because sum of angle on a straight line is 180 degree. Angle Z plus 91, because angle P we got it as 91 degree, equals to 180 degrees. We'll collect like term. This 91 will cross to the other side to go and become negative. So angle Z is equal to 180 minus 91. Angle Z is equal to 180 minus 91. Let's do the subtraction. 180 minus 91. 10 minus 1, 9. 7 minus 9, you cannot borrow 1. 17 minus 9. That will give us 89 degrees. So this angle is 89 degrees. This angle Z is 89 degrees. Now we can conveniently get this angle using sum of angles in a triangle. Sum of angles in a triangle. So let's move on. Using sum of angles in a triangle, let's call this angle angle M. Let's give it a name, angle M. So that means angle M plus angle Z plus angle 58 equals to 180 degrees, because sum of angles in a triangle is 180 degrees. Angle M plus angle Z is 89 plus 58 equals to 180. Angle M plus 58 plus 89 is 147. 147 equals to 180. We'll collect like term. The 147 will move to the other side. So our M is equals to 180 minus 147. 180 minus 147, that will be 33 degrees. So we have gotten our answer, M equals to 33 degrees. So we're going to stop here. In our next class, we will solve more examples and then move on. Thank you very much. Please don't forget, next week we will return to the normal way we are doing this. We'll make use of our stylus, pen, our iPad, and all our devices. Thank you. Goodbye.